Welcome to the deep dive. Today, we're embarking on a journey to really master one of the most fundamental, yet maybe often underestimated tools in computing,
Yeah, that's right.
the GNU Linux shell. It might seem like, a relic, a black screen, cryptic commands, but stick with us and you'll see why it's actually your direct line to, well, unparalleled system control.
Absolutely. And this deep dive, it's built around a really fantastic article, RHCSA, Deep Dive into the GNU Linux Shell. Our mission today is basically to distill the absolute essence from this source.
Okay.
We want to uncover not just what the shell is or how it works, but really the profound shift it enables in how you interact with your system.
Right.
We'll show you why this isn't just about learning commands, it's about unlocking a powerful new way to work, whether you're aiming for, say, certification or just have that insatiable curiosity.
Okay, so let's cut through the mystery then. What exactly is the shell? It's often described as the primary interface between the user and the OS, a command interpreter. But why does this seemingly basic thing remain so central to GNU Linux, especially now with all the sleek graphical interfaces we have?
That's a really great question, because the true genius of the shell, I think, lies in its text-based simplicity and its versatility.
Yeah.
Unlike a graphical interface, right, which presents fixed buttons, fixed menus, the shell treats almost everything as streams of text.
Ah, okay. Text streams.
Yeah, and that allows you to fluidly combine things, filter data, transform it in ways that would be, frankly, impossible or require custom programming in a GUI.
Right.
Like having the ultimate Lego set for system interaction. You type commands, they get read, executed, could be just displaying a file, could be monitoring complex system processes.
So it's that flexibility.
Exactly.
Yeah.
This whole approach, it originated way back in early Unix systems and became absolutely central to GNU Linux precisely because it makes it so easy to chain commands together, create these highly customized workflows.
And when we talk about the shell, our source makes it pretty clear that Bash the Born-Again shell is the dominant player today. It's the default on most systems, right?
Oh yeah, overwhelmingly so.
So understanding the shell, and specifically Bash, is really the gateway to getting full control over your Linux environment.
It truly is, no question.
Okay, so if the shell is this direct line to your system, how do you actually get to it? The article mentions two main ways: physical consoles and terminal emulators. A console is that direct non-graphical access you might see during boot up or maybe on servers without a desktop.
Right, like a server rack.
Yeah, and then a terminal emulator runs inside your graphical desktop, gives you a window to the shell. What's a sort of practical difference there? Why prefer one over the other?
Well, they provide the same core shell functionality, fundamentally. But many seasoned GNU Linux users, they really gravitate towards terminal-based interactions, just for sheer speed and efficiency. Think about it. Typing concise commands can often get tasks done way faster than navigating through multiple menus and clicking buttons,
Yeah, I can see that. Less mouse work.
Exactly. This method, it just offers greater precision, greater control, especially when you get into more advanced operations.
And for those times when you're juggling multiple tasks, the shell seems really good for that too.
Oh, absolutely. You can effortlessly run multiple terminal sessions or even use these really powerful tools called terminal multiplexers.
Ah, like Screen or Tunmux.
Precisely. Think of them as virtual screens inside your single terminal window. They let you manage several running processes, detach, reattach later. It's incredibly flexible.
That versatility sounds key, especially as the article notes, if you're aiming for certifications like the Red Hat Certified System Administrator, the RHCSA, that's a big deal in Linux admin.
Crucial credential, yeah. Being comfortable in both console and terminal environments is a core skill.
Okay, this is where it starts to get really interesting, I think. Unlocking the shell's real power. Its command structure, it's consistent.
Very consistent.
The source highlights it quite elegantly. You have a command name, then optional options like FAH for help or version maybe.
Flags or switches, yeah.
And then arguments, the targets of your command, like a file name or a directory path. What's so revolutionary about this simple structure?
Well, what's truly fascinating is how this pattern scales. Once you grasp this fundamental command option argument structure, you can kind of intuit how to use almost any new tool on your system.
Ah, okay. So it speeds up learning.
Massively.
Right.
It means thousands of different commands suddenly feel familiar. And the source also emphasizes, and this is critical, that many commands are designed to work together,
Right. Chaining them.
Exactly. You chain them using special characters like the pipe symbol, that vertical bar, or logical operators.
Yeah.
This whole concept of combining simple tools to build complex sequences, that's foundational to shell mastery.
And, of course, with great power comes great responsibility, which brings us to permissions and using sudo for privilege escalation.
Absolutely essential.
Knowing when and how to temporarily get those administrative rights is critical, right? Not just for security, but just to get things done sometimes.
Yeah, you simply can't configure certain things without it. But you have to understand when to use it and why.
The core takeaway here seems to be practice. Consistent, frequent practice isn't just about memorizing commands. It's about building that intuition, that muscle memory.
Couldn't agree more. It becomes second nature after a while.
So when you're spending a lot of time in the shell, efficiency is, well, it's everything, isn't it?
It really is. You want to minimize friction.
And the article points out two incredibly useful features that become your sort of personal efficiency toolkit: command history and tab completion. How do these make such a big difference day to day?
Oh, they're absolute game changers. Truly. Command history, first off, lets you recall previous commands just using the up and down arrow keys. Saves so much repetitive typing.
Yeah, I use that constantly.
But even better is the reverse search function, usually Ctrl+R. You start typing any part of an old command, and it finds it for you.
Oh, wow. That sounds incredibly useful for long commands.
It is. I can't tell you how many times that has saved me from digging through logs or trying to retype some complex pipeline I used hours ago.
And then there's tab completion.
Tab completion, your best friend in the shell.
Huh.
As you type a command or a file name or a directory name, you just hit the tab key.
And it fills it in?
Yeah, the shell automatically completes it. Or, if there are multiple possibilities, hitting tab twice usually shows you all the options.
Okay.
These features, they aren't just minor conveniences. They drastically reduce errors, boost your speed, your accuracy. It feels like the shell is anticipating your next move.
Like autocomplete for the command line.
Pretty much, yeah. But way more powerful.
This next part is where, for me, the shell really transforms from just a command line into this powerful workflow engine.
The composition aspect.
Our deep dive highlights 4 crucial techniques: pipes, redirection, command substitution, and logical operators. How do these build on each other?
Okay, so if we connect this to the bigger picture, these aren't just isolated features. They're like design patterns for interacting with your system.
Design patterns, interesting.
Take pipes, that's simple again. They let you take the output of one command and feed it directly as input to another. This is the essence of composition.
So linking tools together.
Exactly. Building complex operations by stringing together simple, focused tools. Imagine, like, filtering a massive log file and then counting specific errors, all in one single line of code.
Oh, okay.
Redirection, then, uses symbols like or gay. It lets you save command output to a file, or append to it, or even use a file as input for a command, essential for capturing data or doing batch processing.
Makes sense. Saving results or feeding data in.
Then you have command substitution, often using backticks or bang. This lets you use the output of one command directly as an argument for another command.
Oh, okay. So the result of one command becomes part of the next command.
Precisely. This enables truly dynamic automated tasks. You can build commands on the fly based on current system state, for example. That sounds powerful.
It is. And finally, logical operators, like and order, which means do the next command only if the previous one succeeded, or which means do the next command only if the previous one failed.
Conditional execution.
Exactly. Building intelligent workflows that can react to success or failure. Mastering these 4 methods, pipes, redirection, substitution, logical operators, gives you this rock-solid foundation for advanced scripting and automated system management.
It's really how you move beyond just single commands to orchestrating entire processes, isn't it?
Exactly. You're conducting the system, not just playing single notes.
Our deep dive continues into how you can personalize things, automate your shell environment using variables and aliases. Why are these more than just simple shortcuts? How do they really streamline things?
Well, think of them as customizing the shell to fit your personal ergonomics, making it work for you.
Variables, for instance, store reusable values. Could be numbers, text strings, even the results of commands. This makes it super easy to reuse common values, like maybe a directory path you access all the time, or certain configuration settings.
So you don't have to type them out repeatedly.
Right, and environment variables are a special type. They aren't just for your current shell session. They affect other programs too. They configure system-wide settings like, say, your default text editor, or where the system should look for executable programs, the path variable.
Gotcha. System-wide settings.
Then you have aliases. These are your personal shorthand. They let you create short, memorable names for long, complex, or just frequently used commands.
Like a nickname for a command.
Exactly. You could alias a command that has, like, 5 different options you always use, down to just 2 or 3 letters.
Yeah.
LZILF becomes L, for example.
Yeah.
That's a common one.
I've seen LL, so that's likely an alias.
Very likely. It means less typing, fewer errors, and just a more efficient and predictable shell session every single time. It's about making the shell work for you, molding it to your needs.
Okay, so you've set up these great variables, these handy aliases, but what happens when you close your terminal or reboot the machine? Our source clarifies that by default, those changes are temporary, right? They just vanish.
That's right. They only exist for the current shell session, which raises the important question of persistence.
Yeah, how do we make these customizations stick around for good?
To make your shell settings permanent, you need to store them in specific configuration files, files that the system automatically reads whenever a new shell session begins.
Configuration files. Okay, which ones?
Well, for the bash shell, which is the most common, the key files are usually in your home directory. Basher shell is a big one. That's typically for interactive, user-specific settings, things like your aliases, your custom command prompt, function definitions.
So Bashrik for interactive stuff.
Yeah. And then there's .bash profile or sometimes .profile. These are often read for login shells, things you want set up once when you log in. There are also system-wide files like etceteraprofile or files in etceteraprofile.d that affect all users, but usually you'll customize your own .bash rc or .bash profile.
So you just edit these files, add your alias definitions or variable exports in there?
Pretty much. You just add the commands you want to run automatically to the appropriate file. Then the next time you start a shell, they'll be applied.
Do you have to restart the terminal right away?
Not necessarily. To apply the changes immediately in your current session, you can use the source command, like source.bashrc. That tells the shell to reread that file now.
Ah, okay. Source. Good tip.
Mastering this process ensures your personalized environment is stable, consistent across sessions. It really boosts your long-term productivity.
Makes sense. Set it up once, benefit forever.
Exactly.
Now, even the most, seasoned sysadmins get stuck sometimes, or need to look up how a command works or what options it has.
All the time. Nobody remembers everything.
Thankfully, the GNU shell has amazing built-in documentation. Our source rightly emphasizes the most important tool here is the man page system. Manual pages. How do these work as a self-help guide?
Man pages are basically the definitive reference documents. They exist for nearly every command, system call, file format. You know it.
How do you use them?
Super simple. You just type man followed by the command name. So man help gives you the manual page for the alias command.
And it just shows up in the terminal.
Yep. You'll get detailed explanations of what the command does, all its available options or flags, and often some usage examples too. You navigate using arrow keys, page up, down, and quit with Q.
The source mentions sections too, like man5 password.
Right. That's a really important detail. Man pages are organized into sections by topic. Section 1 is usually user commands. Section 5 is file formats. Section 8 is system administration commands. So man password might give you the command to change passwords, Section 1, while man5 password gives you the documentation for the etc. password file format itself.
Ah, knowing the section helps you find the right type of information.
Exactly. It prevents confusion.
What about other help? Are man pages the only option?
No, definitely not. Beyond man pages, there's also the info command. It often provides more structured, kind of hyperlinked documentation, though some find it less intuitive than man.
Okay.
And many, many commands offer their own quick help options. Usually help, or sometimes just H. That often gives you a concise summary of options right in the terminal.
That's handy for a quick reminder.
Very handy. Plus, you'll often find extensive extra documentation, like readmazes or examples, tucked away in directories like uschairdoc, followed by the package name.
Wow, so help is everywhere if you know where to look.
Pretty much. The ability to quickly find and understand this documentation is honestly a superpower for troubleshooting and just continuous independent learning in Linux.
We've talked a lot about bash. And for good reason, it seems. Our source confirms the born-again shell is the undisputed default, the most widely used shell on GNU Linux.
Yeah, it's ubiquitous.
It's a direct descendant of the original Bourne shell, Kontrish, but with lots of enhancements. What makes bash so versatile and dominant?
I think bash's versatility is its core strength. It works brilliantly as both An interactive shell, the thing you type commands into directly, and as a really robust scripting language for automation.
So it does both jobs well.
Extremely well. It comes packed with advanced programming features you might expect in a dedicated language. Conditional statements, filets and else, loops, a while, functions, arrays. This means you can write incredibly powerful automation scripts right within your familiar shell environment.
That dual role makes it the sort of everyday hero for most users and administrators then.
Absolutely. It hits a sweet spot of interactivity and scripting power.
But Bash isn't the only option out there. The source briefly touches on some alternatives, each maybe with its own niche.
That's right. It's good to be aware of them. For instance, there's Kalish, the C shell. As the name suggests, it has a syntax that feels more like the C programming language, historically popular in some academic circles.
Okay. C shell.
Then there's K-Kitch, the Korn shell. David Korn developed it at Bell Labs. It was known for being powerful, quite performant, and having advanced scripting features even before Bash, caught up in some areas. You still find it in some enterprise environments, especially older Unix systems or where specific legacy scripts exist.
Corn shell. K-ish.
Got it. There's also TCS, which is basically an enhanced version of Cache, adding things like better command line editing and completion.
An improved C shell.
And then you have shells like Ash, the Almquist shell, or its descendant Dash, which is often the default bench on Ubuntu systems. These are designed to be very lightweight, POS-SAX compliant shells. You find them often in embedded systems or resource-constrained environments where Bash might be considered too heavy.
So smaller, faster, more basic shells for specific needs.
Exactly. Understanding that these alternatives exist broadens your perspective. It prepares you to work in diverse environments where you might encounter a system using K-Chesh or Dash for specific reasons, even if Bash remains your personal daily driver.
Okay, bringing all these pieces together then, how does the shell fit into the big picture? The overarching task of managing a GNU Linux system. The source says it's one of the most important tools. I'd argue maybe the most important. What's its ultimate role?
Yeah, I'd lean towards the most important as well, especially for administrators. It's essentially the administrator's direct control panel. It provides an immediate, incredibly powerful way to control, configure, and maintain the entire system.
Direct control.
Think about the core tasks: managing users and groups, adjusting file permissions, configuring network interfaces, monitoring system performance, installing and updating software.
You do all that from the shell.
Often, yes, especially on servers or remote systems that might not even have a graphical interface installed. In those cases, the shell isn't just an option, it's often the only way to get things done.
Right, headless servers.
Exactly. And the automation aspect we touched on, it's a huge differentiator. You can write scripts, even simple ones, for routine tasks. Think backups, system updates, rotating log files.
Automating the boring stuff.
Precisely. Saving immense amounts of time, but also dramatically improving accuracy by eliminating the potential for human error in repetitive tasks.
That's a huge win.
Plus, the shell gives you instant access to critical system logs and a whole arsenal of powerful troubleshooting tools. And for remote management, essential commands like sush for secure connections and tersing for efficient file synchronization are all shell-based.
So, sush into a server and you're right there in the shell managing it.
That's the standard workflow for millions of servers worldwide. So yeah, shell proficiency isn't just nice to have, it's absolutely essential for handling everything from the most basic tasks to advanced large-scale system automation.
Wow, okay. So we've just completed quite a deep dive into the GNU Linux shell. We've covered its fundamental role as that primary system interface, how you actually access it, and how to effectively use its commands with that core structure. We explored harnessing those powerful efficiency features like command history and tab completion. And we really unlocked the workflow potential of pipes, redirection, command substitution, and those logical operators.
Yeah, the building blocks. We also delved into customizing your environment with variables and aliases, making those changes permanent so you have a consistent experience, and crucially, how to leverage that built-in documentation like man pages so you can be self-sufficient.
Right. Learning how to learn.
Exactly. We touched upon Bash's dominance, but also the existence of alternatives. And finally, really hammered home the shell's vital, honestly irreplaceable role in system management, automation, and remote control.
So what does this all mean for you, the listener? Mastering the GNU Linux shell, it isn't just about memorizing a list of commands, is it?
Not at all.
It's about learning a powerful, surprisingly elegant language that gives you unparalleled direct control over your system. It really transforms you from maybe a casual user into a true architect, a commander of your digital environment.
Yeah, it unlocks incredible efficiency and the ability to automate tasks that might seem incredibly complex otherwise.
It's about moving beyond just what a graphical interface lets you click on and truly building your own solutions, your own workflows.
So the question to ponder is, what new possibilities does this direct, powerful interaction with your system open up for your projects or maybe your career?
We hope you enjoyed this deep dive into the GNU Linux shell. Until next time, keep exploring, keep learning, and keep getting well informed.